Lab 1 is the pole-top transformer insulation testing. This is a very old model of the pole-top transformers, and inside is a transformer. It's got the two high voltage terminals here, and it has the low voltage terminals. So this is 7200 volts primary. So secondary for residential is 240 volts with a center tap, which is our neutral, so we get 120 and 120. Inside also has a tap changer. You can boost the voltage either 4%, 9%, or 13.5%. 4.5% actually. So what that does on a long road, these lines are running down the highway for kilometers. At the far end, the line loss is going to drop the voltage to the customer. Customer might not get 240 volts, so they might get 220 or 210. So you can use this tap changer just to boost the output up a little higher. When you're doing your measurements on this, there is a ground lug right here that's copper and that's bonded to the case. That will give you your best reading. What you're going to do is follow the lab instructions. You're going to use a multimeter first and measure the resistance of the windings and the secondary, and then the resistance of the primary. You could say this is X0, X1, X2. So you do here to here, here to here, here to here. And then you'd measure the primary just with the ohmmeter, and you can write those readings down. Then you're going to use the Megger, and you're going to Megger out high voltage to low, high voltage to ground, and then low to ground. And that will test the insulation. And then you're going to reverse the connections, because what happens is you get a bit of a capacitive charge built up. And you'll see what happens when you flip your leads and measure it in reverse. So these transformers get old. You want to test the resistance of it. Part of preventative maintenance is recording these values on a regular basis. As long as the values don't change, then the equipment hasn't changed. But as soon as some of your readings start to change, historically you can see that resistance is starting to decrease and decrease. Or in the case of other devices, maybe it's increasing, maybe the current is increasing. Then you know that there's some maintenance required. So you can catch something before it blows up and fails utterly. So that's the purpose of preventative maintenance, is checking and testing and recording and noticing trends that predict some type of failure. So you're going to use three methods. You're going to use the Megger method. Then you're going to use a voltmeter method. All you're going to do is put a voltmeter in series. So it acts like a resistor. But before you put it in series, you're going to take another voltmeter and hook it up and set your voltmeter to read DC volts and see what the resistance is. This one is about 11.11 meg ohms. So effectively, you're putting an 11 meg ohm resistor in here, and you're going to provide 100 volts DC, and you're going low side to ground. Well, you're going to do a couple of readings. You can follow them. Here's our standard power supply. We can use the adjustable DC. This is all AC, don't use that. And you're going to set it, put a meter on there, hang a meter off there before you take your leads off, and leave it there so you can just tweak the voltage to exactly 100. If it isn't 100, just record what it is so you can get as close as you can. So then when you put voltage, you're going to see how much current flows with an 11 meg ohm resistor in here. From that, doing the math to determine the resistance. You know the voltage, you know the current, you can calculate the resistance using Ohm's law. That is the ohmmeter method, or voltmeter method. And then same thing, I'm going to put 100 volts, just put a microammeter in there. Some of these meters will do microammeter. This one will. The 177s will not. So you have to get one of the 87s before you can get your microamps and milliamp settings. Okay, so the 3 method, and then read through the rest of the lab and take the readings in sequence. There's a section in the lab here on the components of currents during testing of insulation, and it explains it as to why. You get a capacitive effect, you get surface leakage, you get internal leakage, and you get absorption current, which slowly decreases. And those are, so read up on that. The lab sheet's got good information. Read the entire thing.